it. Dun, 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 it. Dun, dun, dun. Okay, microphone is good. This should work, I guess. Okay. Okay, now it will be much better. Let's go, let's go.
This. So 3 will be the third root of 27. Why? Which is the part. Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So we will be continuing with our binary search playlist, which is the part of the Strivers A to Z DSA course. In case you haven't checked it out yet, there's a link in the description. You can definitely check it out. So today's problem will be find the nth root of a given integer m. So what is the problem state? Imagine you're given an integer 27. You have to find the third root of 27, which basically
find the nth root of m. Okay, n கொடுப்பாங்க. They will give us n and they will give us 27 also. Then n is equal to 4. Then they will give m is equal to 69. Okay.
means this. So 3 will be the third root of 27. Why?
Okay. Okay. Square root of 27 வெளியே 3 இருக்கும். Then 3 into 3 into 3 27. So அதனால that's why 3.
Because 3 on being multiplied thrice will give you the number 27. But if I take one more example, let's take this example, m equal to 69. I ask
Okay.
you to find the fourth root of 69. You will not find any. Why? Because imagine you take 1, you multiply it 4 times, that gives you 1. If you take 2, you multiply it 4 times, you get 16. If you take 3 and you multiply it 4 times, you get 81. So none of the numbers, because 3.
Okay, let's assume 4 into 4 into 4 into 4 into 4. என்ன வருது 4 4 4 power 4 power 4 256 வரல. அதுக்கப்புறம் என்ன பண்ணோம்?
On being multiplied thrice will give you the number 27. But if I take one more example, let's take this example, m equal to 69. I ask you to find the fourth root of 69. You will not find any. Why? Because imagine you take 1, you multiply it 4 times, that gives you 1. If you take 2, you multiply it 4 times, you get 16. If you take 3 and you multiply it 4 times, you get 81. So none of the numbers on multiplying 4 times will give you 69. So there doesn't exist a fourth root of 69. Thereby the answer will be -1.
ஓகே. இம்பார்ட்டன்ட் பாயிண்ட் நோட், இந்த வெளியே இருக்கிற 3 வந்து ஜஸ்ட் இது 3ங்கிறது இங்கே வந்து அது மேபி அது 1 into 1 into 1 இருக்கலாம், இல்லை 2 into 2 இருக்கலாம். இன் திஸ் கேஸ் we have been lucky, I guess, in this particular இது 3 into 3 3 into 3 into 3 வந்து 27 இருக்கிறதுக்கு. பிகாஸ் இதில் n is equal to 4ன்னு கொடுத்தா 4 into 4 into 4 into 4 தானே போடணும். 1 into 1 into 1 into இதுக்கு போட்டோம். ஸோ ஓகே, இம்பார்ட்டன்ட் பாயிண்ட் அதை நோட் பண்ணி வைக்கணும். ஹவு கேன் ஐ நோட் 3 is just outside number to know how many time I need to multiply a particular element. Okay, show time. 4 இது இங்கே எடுத்துக்கலாம். இப்போ இதை எழுதிக்கலாம். n is equal to 4, m is equal to 69. முதல்ல 1 into 1 into 1 into 1 1 no வராது. Then 2 into 2 into 2 into 2 2 to 4 4 to 8 8 to 16 வராது. 3 வராது வராது. We have no luck. So இதுக்கு answer this will be like what, -1? Yeah.
Multiply it thrice, I'll give you the number 27. But if I take one more example, let's take this example, m equal to 69. I ask you to find the fourth root of 69. You will not find any. Why? Because
How is my status of my live stream? Okay, not good, not bad.
imagine you take 1, you multiply it 4 times, that gives you 1. If you take 2, you multiply it 4 times, you get 16. If you take 3 and you multiply it 4 times, you get 81. So none of the numbers on multiplying 4 times will give you 69. So there doesn't exist a fourth root of 69. Thereby, the answer will be -1.
Fourth root of 69 doesn't exist. So return -1.
How do you solve this problem? Now, if I ask you to do it by linear search, the problem is super simple. What you do is, you take 1 and you're like, okay, 1 into 1 into 1, not possible. 2, 2 into 2 into 2, not possible. 3, 3 into 3 into 3, yes, 27, possible. I got my answer. And you're done. So if you take this example as well, 1 into 1 into 1, 1. 2 into 2 into 2 into 2, 16. Nah. 3 into 3 into 3 into
Okay, brute force approach எழுதுவோம் ஏன்னா it might help us in what case? Let's assume brute force we need to run run a loop 1 into 1 into 1 into 1 2 into 2 into 2 into 2 3 into 3 into 3 into 3, something like that. It will give 27. So 3 is our answer. Okay.
3, 81. Oh, it exceeded. It exceeded 69. I never reached 69. Never not possible. So linear search will be super simple. You straight away go and run a loop from 1, and the maximum answer can be the number itself. You just do this, and you call some function, and you say him, hey, I raised to the power n, because if I give you 1, you have to multiply 1 4 times. In case I'm finding the fourth root, you have to multiply 1 4 times. If I give you 2, you have to multiply 2 4 times. So this will be done by function. You can write it yourself. And if that's equivalent to what I'm looking for, which is m, this I is my answer. Or else, if this value has exceeded, very important, this value has exceeded, I can never find my answer because the multiplication has exceeded. In that case, you can just break out this for loop, and right at the out of the for loop, you can write return -1. So this will be the extreme naive brute force solution. So if I have to talk about the time complexity, this is a big O of m because you're running a m loop. Ideally, it will never go till m, but yeah, in the worst case, it might end up going till m. If you give this as 1, it might end up going till, like, if you have to find the first root of 69, it will go till that. So yeah, ideally, at the worst case, it will be m. What about this? You run.
Okay. Now where is this brute force? I need maybe I should see the what we are passing. Where is the helper function, man? He told you to write. Oh, he is computing power by manually. Okay, this is also not bad. This is also not bad. This should also work. This also should work, right? Find the nth. Okay, let's code this up. I'm pretty much confident I can do this. Let's see. Okay, we can do this, right? What is this? Feed input variable. I don't give a shit. Binary search. Okay, we can do linear search also. Um, find you are going to find it. Okay, we will start with 1, right? Is equal to I less than m, right? N is the yeah, n is the outside number. So m, no, what am I missing? What am I missing? One, two, three, four. Let's go. Let's see afterwards this thing. Uh, okay, we need to compute power. Um. Oh shit. Oh shit. Oh shit. Power is equal to m. Oh, let's back to the back. Oh my god. Back to the first principle. When we need to compute the power first, then uh, we have to match that particular thing to this. Then if the power exceeded the m, then obviously we can't do any shit. So okay, now I know. Let's go. mm, long 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 we use the inbuilt power. Who cares? Technically it's wrong, but I power, sorry, there will be 1. Then if, oh my god, power equals to m, we can return I. Let's assume we have 27 and n is equal to 3. It will go first 1 into 1 into 1. What is 1 into 1 into 1? 1 power 3. 1. Then loop goes to 2. 2 into 2 into 2 to 16, I guess. I'm bad with math. Then 3, I guess it's 81. Of course, I mugged it up. Okay, if let's assume, let's uh the next number, let's assume 4 and 69. It is not possible. So it will make loop every time if there is no equal condition comes with this particular function. It will directly return -1 because there is no answer exist. So power greater than m, then break, no possible. Okay, Aha. Okay, cool. Oh my god. It was passing. I thought it will pass the test cases. Because loop range, currently loop. But you should be iterating. I am raised to the power of 1 by power calculation. Oh my god, what is happening over here? I don't know. Yeah, I fucked up. Equals to, because 1 2, let's assume what mistake you have done here. Let's say 3. Hmm? It should run until the loop until the third element, the particular element 3, right? So only that loop goes to the third loop and calculates the power. Then only it equals to what is 3 into 3 into 3, 27. Then that particular loop only that answer comes to picture in our case. So we need that, right? Okay, now this will work. This will work. Fingers. What did I do? Power, power off. Um, I think end. Now this will work. Again, fingers crossed. Um, oh my god. I power n, I plus plus. All these things are right. What am I missing? What am I missing? What am I missing? Ayo homa zin. I is equal to I plus plus power return break power equals to m, we return I. What am I missing? What am I missing? Um, for return break, let's ask ChatGPT. Where is the GPT? Do it. What mistake I made? Okay, so we have to typecast then. We can typecast that, right? Can we typecast? Why? Uh-huh. You can type you can typecast, but it's not an actual problem, annoying, but oh shit. Then it won't run, right? Maximum. What's the test case? So again, power 20 means it will go something behind the integer floating point. Okay, this will work then. Round. Round, 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 round. Round. Round function. That's why I love C++. We have all the functionalities. Why am I? Long, long. Why am I doing this? Int. Int. Do it. Da, 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 da. Da, na, 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 na. I'm pretty much fucked up right there. Okay. Please work. Please work. Please work. It won't work, I guess. How the Okay, let's see in another case. Find, find the finding name road. I don't know what is this main function readline. JavaScript. What the fuck is this? This is Amazon Deloitte. Oh my god, what just happened? Control C. Control. Oh my god. See, this will work. I guess that there might be some guardrails. Here, this need to work. Implementation. Yeah. Let's see now this will work or not. I submit. Then there might be some issue with Geek for Geek, I guess. Shitty website. Do it. What did I do here? We need to calculate the power, something like it for, or let's say I need to calculate the power manually. Then what I need to do? I need an for loop for sure. Yeah. Int I is equal to 1. I less than or equal to m. Then I plus plus. Then we calculate the power. Power first will be 1 power 1. So 1 will be there, I guess. So let's see. Yeah. I guessed it, right? So power always will be first 1. So we need to do extensively for into I, right? Yeah, right. That is the power. Okay, let's go to brute force. Brute force. Here also we run the integer I less than and equal to m I plus plus. I need some good music to listen. Study music. Let's do it. Da 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 da. Oh, okay. Power of I into n. So if power equals to m, then return I. If power exceeded the limit of m, right? Then we can't do nothing and we'll break out the loop. Return -1. Okay, now let's see the actual binary.
Running a function where you're saying multiply I n times. If you're given 2, multiply it. If n is 4, multiply it 4 times. If n is 5, multiply it 5 times. Earlier you're saying this. You have to run a for loop. Like, how do you find any number 1 raised to the power 4 or 2 raised to the power 4 or 3 raised to the power 4? There are two ways. Either you run a for loop which will take a big O of 4 time, in this case which is big O of n, or you use the power exponential method which takes big O of logarithmic base to n. So either of them. Either you use this or either you use this. You can use either of them. So I've already taught this power exponential method. I'm not sure if I've taught this or not, but I'll be teaching this in future. You can get this from the internet. It's super simple. So the complexity will be m into logarithmic base to n, given that you use the power exponential method in order to find this value, like I raised to the power n. In order to find this, you'll use logarithmic base to n. So this will be the overall time complexity. Obviously, this is what is kind of not good. Is this the optimal approach? No. Why? Because we're using a big O of m and I need to optimize it. And this is where something like binary search on answers will come in. Can I apply binary search on answers? Probably I can. Why? I'll tell you. So I was being asked to find, imagine I've been asked to find, okay, the fourth root of 69 in this case. What did we do? Okay. Like we took 1 and 1 into 1 into 1 into 1 was 1. And we said it's not possible. Yeah. I have a simple question. Why did you go to the next number? Why did you not stop? Because the value that you got was lesser than 69. So internally you thought, maybe I can slightly increase the number. And if I slightly increase the number, I might end up getting there. Thereby, you went ahead and increased the number to 2. That is the reason you did it. And then you were like 2 into 2 into 2. And it was like 16. You're like, no, this is not, still not. And then again you slightly increased because 16 was lesser than 69. And this time you went to 3 and you're like 3 into 3 into 3 into 3. And this time you got it as 81. Why did you stop here? Because you are sure that if this is not possible, like this has exceeded, anything beyond this will not be possible. Because if you do 4 into 4 into 4 into 4, that will always exceed 81. So this is not possible. That's why you stopped. And this is what will help you to find, apply binary search, because you're very sure if it is lesser, you have to move right. And if you're greater, you have to move left. So you know when to move right because it's kind of moving right. And if you're at 5, 5 is not possible. So you move upwards. So you know that direction. So we are seeing a pattern. Can I utilize that pattern? Let's probably take some examples and that might help us. Let's try to find. So we are seeing a pattern. Can I utilize?
n is equal to 4, m is equal to 69. Let's start the iteration. Let's take 1 into 1 into 1 into 1 is equal to be 1, then 2 into 2 into 2 into 2 into 2 will be 16, then 3 comes to the picture, 3 into 3 into 3, what, 81? Not possible. How to return a voice note for this? Okay, let's see.
That pattern. Let's probably take some examples and that might help us. Let's try to find out the third root of the integer 27. Let's try to apply our pattern. I know one thing for sure. The answer is always going to lie between 1 and 27. So remember...
இது எனக்கு first புரியல. I was not getting it. So, okay. Binary search on answers. Now I'm getting it.
Whenever you're applying binary search on answers, it's very important. Whatever minimal you like, whatever value that you think can be your starting answer, you always assign that to no. And whatever you think can be the highest answer, just go and assign that to high. That's the first thing of binary search on. Answers. So you have defined the range. You know the range of answer can lie between 1 to 27. Once you
n is equal to 3, m is equal to 27. So the answer will be answer will be 1 to 27. Okay.
You have declared, you start applying the binary search. So if I ask you where will the mid point to initially, it's 1, it's 27, that's 28. If you add them up, by 2 will be 14. So the mid will be pointing to 14. You're 14. What do you do? That's declared, you start applying the binary search. So if I ask you where...
Start applying binary search.
Well, the mid point to initially, it's 1, it's 27, that's 28. If you add them up, by 2 will be 14. So the mid will be pointing to 14. You're 14.
28 divided 14, yeah. 14 is lesser.
What do? You say 14 into 14 into 14. You can have a function written. You can just ask the function to return the value. 14 into 14 into 14 is actually greater than this 27. What does that signify? Anything like
What is 14 power? Oh shit. 14 power 3. 2000.
anything like 16, anything like 17, everything on the right will always be greater than 27, which means they can never be your answer, Thereby, can I surely say that none of them will be my answer? I can. Hence, I'll eliminate. The moment I eliminate, the high will move to one place lesser than 14. Thereby, the high will come over here, which is at 13. So what I've done is, in a moment, I trimmed down the search space by half. And I was able to do it because I know if something is not possible, anything on the right is not possible. Okay, fine. I eliminate, the high will move to one place lesser than 14. Thereby, the high
This entire side is not possible.
will come over here, which is at 13. So what I've done is, in a moment, I trimmed down the search space by half. And I was able to do it because I know if something is not possible, anything on the right is not possible. Okay, fine. Mid, what's mid again? 1 plus 13, that's 14 by 2, 7. Perfect. What about 7? 7 into 7 into 7.
14 divided by 2 is equal to 7. 7 into 7 into 7 into 7. Not possible, I guess. 7 power 3. 333. Greater than 27.
whatever value you get, that's greater than 27. I'm like, if that's greater than 27, everything will actually be great because they can never be your answer. You're like, okay, let me do 7.
Here comes the fun. 7.
7 by 2 is 3.5, so 3. So mid is pointing to 3. This is the point. You're like, okay, let me do 3 into 3 into 3, 27. I got my answer. Stop the binary search, return. Because remember, over here the question stated, if you do not get it, you have to return -1. So you've got someone, return. You don't have to return the floor value. You just return the exact third root of 27 if there is. No floor, no max, nothing. So you got your answer. Stop and return. Let's take one more example and try to see what happens when the answer is not possible. So in the last example, the answer was possible. What if it is not possible? Let's take an example. N is given as imagine 4 and M is given as 69. For this, if you remember, the answer was -1 because there is no fourth root of 69. What's the range? Yes, 1 and 69. So that's the first step of binary search on answers. Always define the range and assign low and high. Done. What's the next job? Assign mid. What will be mid? 1 plus 69, that's 75. That's 35. 35, yeah. 35. Fourth root. So 35 into 35 into 35 into 35 will obviously be greater than 69. If it is, can I?
It was not obvious. It's the truth. $70 divided by 30. 70. Yeah. 35. 35 into 35 into 35 into 35. Obviously greater than 69. Obviously greater than 69. Then what we need to do?
I say everything to the right will be greater than 69.
Yeah. We got 30, 35. 35, right? Yeah.
Yes. Hence you eliminate the right portion because they cannot be your answer. Thereby this high will end up moving to one place before the mid, which is 34. So just move it. Perfect.
Okay.
Again, I am on the road to eliminate search spaces. I'm over here. What is the next job? Again, find the mid. 1 plus 34, that is 35 by 2, that is 17.5, hence 17.
Mid is equal to 35 divided by 2. I am just dumb, man. and I don't know how to divide or something. What the fuck I do? I just need to study that. 17.5. Okay, let's compute this. 17 in 35 divided by 2, 17.5. Then 17 into 17 into 17. Here we have 4, right? So 17. It's obviously gonna be greater than 69. So 18, 19, 20, 34. I is equal to minus 1, 16. 17 divided by 2. Again? Wait a minute.
Again, if you take 17 into 17 into 17 into 17, if you do this, that's greater than 69. Not possible. Hereby, everything on the right gets eliminated, and this high will be at 6. So mid will be pointing to 8. Where will the mid point to? Perfect. Let's quickly erase everything, and high will be at 16. Where will the mid point to? The mid will point to 1 plus 16, which is 17 by 2, 8.5. So mid will be pointing to 8. Again, the same thing, 8 into 8 into 8 into 8, 16, which is 17 by 2, will be at 16. Where will the mid point to? The mid will point to 1 plus 16, which is 17 by 2, 8.5. So mid will be pointing to 8. Again, the same thing, 8 into 8 into 8 into 8 is greater than 69, hence everything on the right will be eliminated. So it will be like 7, because everything on the right is eliminated, so the high moves. What is the mid?
Divided by 2. 8.5. 8. 8 into 8 into 8 into 8 power. No. 8 power 4. 8 power 4. 4,000. Minus 1. Mid minus 1. 7. 1. 7. Then 7 divided by 2. 3.5. 27 lesser than 69. Now what do we do?
is 4 because 1 plus 7 by 2 is 4. 4 into 4 into 4 into 4 is again greater than 69. So everything on the right is eliminated. So eliminate, and this moves to 3. So I will move to 3. Let's quickly do it now. We're almost there. What will be the mid? 2 into 2 into 2 into 16. If it is less than 16, it's equal to 69. It's equal to 69. It's equal to 69. If it is less than 69, you do like 1 can mile cannot be moved. The low has moved. The low will move and limits. We are 3. Okay, because we went to 3 into 3 into 3 into 3 is 81 rather than 69. So 3 can never be answered. So the right portion will be eliminated. I will move please mid. Stop. The moment you stop, what do you see is here? Lower crust, high crust, no portion where you're equal to same. They are fine. Head turns 1. Quite simple. So the kills are reached on answers. I did the range. Assign low to lowest, assign high to the highest possible answer. Again, in Shady, I taken and can vary as well to optimum. But a classic to cover all cases is to take 1 m minus below 1 because I'll also this. Okay, done. Now type the code. I think it'll be super. I'm going to say function and I take n and I take m. What's the following? N will be 1.
Encoding overload consider பண்ணிக்கணும்.